Welcome to the machine learning course by Pragya. We are at session 5. In this video, we will learn how to estimate the model parameters. What's the model? Model is nothing but the hypothesis. In our example of simple linear regression, y is equal to theta naught plus theta 1 x. We can also say h theta of x is equal to theta naught plus theta 1 x. It is also a good practice if you say it as given below, that is y is equal to theta naught x naught plus theta 1 x. X naught is always equal to 1. We use a gradient descent algorithm to estimate the model parameters. It's a very popular algorithm and it is used widely in machine learning, not only for linear regression but for all other algorithms. Look at the figure. We know the cost function. What is the cost function? It's the mean squared error divided by 2. In this graph, we are plotting the cost function by varying theta naught and theta 1. So you get a two-dimensional picture. You see a spline. Depending on the combination of values of theta naught and theta 1, you will be able to locate the associated cost in the spline. By common sense, we must find theta naught and theta 1 so that the cost is the minimum. So the spline explains how the costs vary with theta naught, theta 1. Definitely it will vary. So our goal is to find out the appropriate values of theta naught and theta 1 that gives the minimum cost. If the cost is high, then error is more. If the error is more, the predictions using the model will have a large error. We want to estimate the parameters correctly so that our predictions are correct. What is the ideal value for the cost? Ideal, it can be 0, but that may be impractical. So we aim at a cost that is closer to 0, maybe 0.001 or 0.0001. Okay, if it's 0.0001, the model is more accurate than when the convergence takes place at 0.001. This is the slide which gives you the gradient descent algorithm. Let us look at the algorithm given on the top of the slide. So repeat until convergence. I'm reading from the slide. Repeat until convergence. Theta j is equal to theta j minus alpha multiplied by the partial derivative of the cost function. The cost function is j theta naught theta 1 and j is equal to 0 or 1 in case of simple linear regression. So that's the algorithm. So we have to repeat it iteratively. We have to find out the new values of theta j for j is equal to 0, comma 1 means we have to iteratively find theta naught and theta 1 such that we reach the convergence. We always start with initial values chosen at random at our will and pleasure, maybe 0, 0 or 5, comma 2 and so on. Ultimately, it leads you to the correct values for theta naught and theta 1. So we start with the new values. So we start with the values chosen by S. Now we find the new value for each of the theta j. J is equal to 0 to 1. We use a gradient descent algorithm. So new value of theta naught, look at the algorithm. New value of theta naught is equal to old value of theta naught minus alpha multiplied by the partial derivative of the cost function. What is alpha? Alpha is the learning rate. Each step is determined by the value of alpha as well as the cost function at that point. The cost function will vary with different values for theta naught and theta 1. Always smaller steps you should take. If you take larger steps, there will be problems. The second term on the right hand side of the algorithm gives us a direction to move. If it is negative, then we move up, because the new value of theta j will be larger than the old value of theta j. If it is positive, then we move down. So we move in the direction of steepest descent. Look at the figure. You are seeing a typical learning curve. In the y-axis, you see the cost. The initial weight is nothing but the old parameter value or the current parameter value. So the initial weight gives you the current parameter value. The new parameter value is found moving down. So in this figure, we have on the right hand side, you have the parameter values, and with every iteration, it keeps going down incrementally. It goes on till we reach the convergence, that is tip of the curve. The gradient is the tangential line to the cost function curve, as shown in the figure. Look at the tangential line for the at every point, at every step, is a tangential line. A weight or parameter, they are the same. What should be the value of alpha? The learning rate. If it's too small, then as shown in the right hand side figure, the learning may take more time. The number of steps to reach the minimum cost will be slow, will be large. On the contrary, if it is too large, then the parameter value will travel in a zigzag manner, and we may miss the optimum point. So it's better to err on the right side. Don't err on the wrong side. So if you're not sure, you make the learning rate as small as possible. I would suggest a value for alpha as 0.0001 or 0.001. You can always experiment and find and fix up the value of alpha. But fixing up the right value of alpha is critical for success in the machine learning. We now look at the partial derivative part of the gradient descent algorithm. When we differentiate the cost function, 2 and 1 by 2 gets cancelled out. It gets reduced to h theta x minus y multiplied by xs. Look at the last line. We did not worry about the inverted lines. So the partial derivative is equal to h theta x minus y multiplied by xj. What is h theta x minus y? That is the error. In fact, total error. Okay. So there is a little difference between theta naught and theta 1. We'll see it. We'll look at it now. So now we can rewrite the gradient descent algorithm, explicitly saying what is theta naught and what is theta 1. So new value of theta naught is old value of theta naught minus alpha by m multiplied by the total error of the training example. Total error of all the training examples. But when we calculate the other theta values, we have to multiply the error in each example by the corresponding value of x. So that is why for theta 1, when we say theta 1, new value of theta 1, the old value of theta 1 minus alpha by m, the summation of I is equal to 1 to m, error multiplied by the corresponding value of xi. We total it, then multiply by alpha by m to get the how much you should increase or decrease the value of theta 1. A word of caution at this stage, you should update the value of all parameters simultaneously at the end of the iteration. In other words, theta naught will be updated after you find theta 1. Don't do it immediately. This is the essential advice of the gradient descent algorithm. Let us take an example to understand the algorithm, how it works. The two tables given in this slide, table 1, table 2. Table 1 in the top gives the training data set in the first two columns. We have the values of x and the corresponding y value. This was collected from the field, or this is a past example, past experience. We have this x and y. Say for a given problem, for example, the marks obtained and hours of study. The marks obtained is y and hours of study is x. So this cannot be changed. We select the initial values as 0 and 1. Theta naught is equal to 0 and theta 1 is equal to 1. Now we find the estimated value for each of the x for these two values of 0 and 1. That is given in the third column of table 1. So here, because theta naught is equal to 0, y is equal to theta 1 x. So the y estimated for each of the x itself. For 1 it is 1, 2 it is 2, and so on. We now know the actual value of y and the estimated value of y. The error at each step is the estimated value minus the actual value. So for example, the error for all the examples turns out to be minus 1. For example, the first training example, y estimated is 1 and y is 2. So 1 minus 2 is equal to minus 1. That's the error. Now we get inside the gradient descent algorithm. So theta naught is equal to theta naught minus alpha by m multiplied by the total error. So theta naught is equal to, in this case, initial value was 0 and the error is minus 3 and number of training example is 3 and we choose learning rate of 0.1. So you get 1 by 3 multiplied by 0.1 multiplied by minus 3. So you get 0 plus 0.1. 0 is the old value of theta naught. So the new value of theta naught is equal to 1. But when you want to estimate theta 1, you have to add one more factor. That is the error at each of the training example, you have to multiply by the corresponding value of x. So theta 1 is equal to theta 1 minus 0.1 by 3. 0.1 is the learning rate and 3 the number of training examples. So now for each of the training examples, the first example minus 1 is the error and the value of x is 1. So minus 1 into 1. The second example minus 1 is the error, 2 is the value of x, minus 1 into 2. And third example minus 1 is the error, 3 is the value of x, so minus 1 into 3. So you get 1.2. So the new values you got, theta 0 is equal to 0.1 and theta 1 is equal to 1.2. Now we have to calculate the cost function corresponding to the new values of theta naught and theta 1. It is shown in table 2. We have to calculate the y estimate corresponding to each x. For instance, for the first training example, it is theta naught is equal to 0.1 plus theta 1 is 1.2 multiplied by 1. 0.1 plus 1.2 multiplied by 1 is equal to 1.3 as shown in the table. Similarly, we find out for the other training examples. Once all the three estimated values are known, are calculated, we can find the squared error. Error is estimated minus actual and you square it up. So for the first one, it is 1.3 minus 2 whole square, that is 0.49 and so on. The total error works out to be 0.83. So the cost is 0.83 divided by twice into number of training examples, that is 2 into 3, which is equal to 0.14. So our cost function or the cost is 0.14 when we choose theta naught is equal to 0.1 and theta 1 is equal to 1.2. So we are not yet reached the target. Our target is 0.001 for the cost. So we have to iterate again. We do this iteration till we reach the target, that is the cost gets reduced to less than or equal to 0.001. Dear viewers, we saw the step-by-step approach to estimating parameters. We used gradient descent, a very powerful algorithm, not only for linear regression, but for many other machine learning problems. If you like the video, please subscribe to the Pragya channel for free. And it's absolutely no cost for you. That's all for now. Until we meet again, bye bye.